Today we're going to talk about transformations of functions. You should be able at the end of today's lesson to state transformations of an absolute value function, and you're going to be able to graph absolute value functions using transformations. The parent function you will see all throughout Algebra 2. What you're talking about with the parent function is the simplest of graphs in a family. What you will do with that graph is transform it to create other members in a family of graphs. The first basic function that we're going to transform is the absolute value function. As I said, you're going to transform families of functions of graphs throughout the course. Every function that we look at, we do transform. So, absolute value. F of x equals the absolute value of x. What this graph looks like is a V shape. Now, if we think of how we get this graph, if I was going to draw this for the first time, if I made a table, which we won't have to do because we're going to just shift it. If you put 0 in for x, the absolute value of 0 is 0. If I put 1 in for x, the absolute value of x, absolute value of 1 is 1. Absolute value of 2 is 2. If I do the absolute value of -1, the absolute value of -1 is 1. The absolute value of -2 is 2. Plot those points 1, 1, 2, 2, -1, 1, -2, 2. You get this V shape. Highest or lowest point would be called the vertex. The parent function, the vertex is 0, 0, and it's the lowest point because it's a right side up V. What's going to happen is that thing is going to flip, and then it would become the highest point. Domain, you can take the absolute value of anything. So your domain is going to be -infinity to infinity. All x's will work. If you look at your range, you're not getting y's below 0. There's no y's down there. The first y you get is at 0, and they're going up. So your range is going to be y's that are greater than or equal to 0. If you want to put that they're going to go to infinity, that's fine. What we're going to see is we're going to put numbers in that equation. We can put a number in front, we can put a number inside, or we can put a number at the end. They're going to move that V. Okay, so how are they going to move it? A translation will move your figure up, down, right, or left. A reflection is going to flip the figure over a line of reflection, and a stretch or shrink is going to shrink it or enlarge it proportionally. Now, in the case of lines, which really a V is made up of two rays intersecting at a point, what it's going to do is it's going to change the slope. The V will look narrow or wide. Now, how we're going to do this is I'm going to put these in a graphing calculator. And if we can see what happens when we're putting this in the graphing calculator, if I put the absolute value of x, what I will get, if I can do it, absolute value of x, if you graph it, comes up this V shape. If we do the next one, where we put the absolute value of x and we add 4, it looks like it's moved up 4. If we look at the absolute value of x minus 3, what's happened is the V shape has moved down 3. So absolute value of x plus 2 is going to move up 2. So it appears that what this k is doing is making it go up or down on the y-axis. Okay. Look at the number inside. So again, if we look first just at absolute value of x, you graph that shape. There's my absolute value of x. If I change it and do the absolute value of x minus 3, strangely, it moved right 3. If I look at the absolute value of x plus 4, what's happened now is it moved left 4. So when we look at that, what's actually happened with that is whatever that number is inside, it moved right or left the opposite direction of what you would think. A negative moved right and a positive moved left. So it moved left when you saw positive, it moved right when you saw a negative. If I put a number in front, go back to our original absolute value of x, we have just again the regular old V shape. If I put a number in front of that, so I put 2 and I graph it, it's become more narrow when we look at that. If I put 5 in front of it, 5 times the absolute value of x is even more narrow. If I put 0.5, which is a half, times the absolute value of x, it's become wider. That actually deals with slope. If you look, you went up 2 over 1, up 2 over 1. Here you're going up 5 over 1. Here you're going up 1 over 2. So the fraction, this number out in front, is like the slope. If we put a negative out in front, so if I put negative just absolute value of x, what's going to happen is instead of being right side up, now your graph is upside down. So to simplify, to fill this in, the number out in front, if it's negative, it's going to flip over the x-axis. If it's a number, it's going to be your slope. The number inside the absolute value, what that's going to make it do is it's going to make the V shape move left or right in the opposite direction. Okay, and if it, just to understand what I'm saying, if you see a plus, it's actually moving left. If you see a minus, it's actually going to move right. The number at the end, the K, is going to move up and down correctly. So what do I mean by correctly? Plus means up, minus means down. Now, to put this together, in general, So what's going to happen for the rest of the year? Because these shifts will not change. Whatever function you have, f of x is going to change. If we add or subtract a number, it's going to move it up and down correctly. Up is plus, down is minus. If you add or subtract inside the function, that's going to move it right or left the opposite way. So right would be minus, left would be plus. If I have a negative in front of my function, it's going to reflect over the x-axis. If I have a number being multiplied by the function, it's going to stretch or shrink it vertically. In the case of absolute value, as I said, it's going to be your slope. So how are we going to graph absolute value? First step, you're going to look at the function and you're going to think, where is it moving? Is it moving right, left, up, or down? Move from 0, 0, whatever it is moving. That's going to be your vertex. Then, to get the shape of the V, you're going to use that number that is out in front. Now, if there is no number, it's 1. So it would be up 1 over 1 in both directions. If it's a half, I'm going to go up 1, right 2, up 1, left 2. If it's negative, I'm going to move, let's say it was negative 3, down 3, right 1, down 3, left 1, because you have to make the V shape. So we're just going to look at some examples. Absolute value of x minus 4. This is going to make it move down 4. It didn't move right or left. So from 0, 0, I'm going to move down 4 and put it out. Slope in front is 1 over 1. So I'm going to go up 1, right 1, up 1, left 1. There's the V. Domain. You can take the absolute value of anything. Your domain is always going to be negative infinity to infinity. Range, look at what your y's. If you look down here, that's the first y value that occurs. There's nothing below it. All your y's are above. So your range is going to be negative 4. Y is greater than or equal to negative 4. Again, if you want to put infinity, you can because it's going up. Okay, 1/3 x. Didn't move right or left, didn't move up or down. Vertex is 0, 0. This is my slope. I'm going to rise over run. Up 1, right 3, up 1, left 3. There's my graph. Domain, again, negative infinity to infinity. Range, it didn't move the first y, it didn't move up or down. So the first y, the lowest y is 0. Your y's are greater than or equal to 0. You want to put to infinity, that's fine. Now, I'm not going to do all of these because I want you to maybe do one. So I'm going to leave that one blank on your paper. You do it. Fourth one, absolute value of x plus 4 minus 2. This is going to make it move right and left the opposite direction. So it's going to go left 4. This is going to make it move down 2. So you're going to do both those moves and put it up. Left 4, down 2. There's my vertex. Slope is 1 over 1. Up 1 over 1, up 1 back, left 1. There's the absolute value. Domain, negative infinity to infinity, always. Range, your lowest y value is negative 2. It moved down 2. It's pointing up. So I'm going to have my lowest y is negative 2. It's going to be going to infinity. Okay, let's look at, this is probably number 6 on your paper. Again, where's it shifting? Left 1, up 4. So I'm going to move left 1, up 4, put a dot. That's my vertex. This is my slope. It's negative. So since it's negative, instead of moving up 2 over 1, I'm going to move down 2, right 1, down 2, left 1. My absolute value is reflected, which it should be because of that negative. Domain, always all real numbers, negative infinity to infinity. Now, if we think about our range, there's no y values up here. The highest y value is 4, and it's pointing down. So that means your y's are going to go from negative infinity until you get to 4, and 4 is going to be the highest point. So any of the graphs that are left, you try for homework, not for homework, but to have it for class tomorrow, and we'll see tomorrow in class what you learned from the video. See you tomorrow.